We are generating 1 trillion megabytes of data every day. Our laptops are overflowing with backups. Our phones are going out of storage. And we don't even know what is happening with the data that we store in cloud. In the context of enterprise, how do we manage this enormous data and get actionable insights in near real time? The existing tools are highly inadequate, and therefore, there is a need to reimagine the data analytics. Hi, I'm Ajay Malgaonkar. I head the engineering for Prolifix India, and I'm here to talk about building a future-proof solution architecture for your data analytics. Evolution of data analytics. It goes hand in hand with technology evolution over past 3 decades, from the 80s and 90s to early 2000s, a decade of 2010 onwards, and very recently a new decade of 2020. Similarly, data analytics has evolved over years. In the early 90s and 2000s, from the Microsoft Excel to Access to DBase, Foxbase, and ETL data warehousing and reporting solutions. The dawn of the big data in the decade of 2010, ever increasing processing power, cheaper storage solution, and advent of cloud gave rise to data lakes. 2012 onwards, data lakes gained popularity in storing the data in a very raw form, in the form of segments, and separating it out from the compute and the more proprietary RDBMS solution. Come 2020, the need for real-time analytics is demanding the historical data to mesh with the current data in a near real time and provide you an accurate, actionable insights. This leads to a new pattern in analytic architecture called lakehouse. So what's the trigger point for this evolution? Simply the explosion of data, the tsunami of data. The world has generated 64 zettabytes of data in 2020. That is 10 raised to the power of 9 terabytes of data. Half of the world's data is generated in last 2 years, and it's exponentiating. As per the Google, 0.05% of this data is analyzed. Let's look at what are the real life challenges faced by the organizations. This is Evergreen, 20,000 metric ton container ship, which got stuck in Suez Canal, costing the world $10 billion of trade, stuck in water. And look at a poor digger who's trying to free him up. Enterprise data management is such a monster that current technologies are not enough. Challenge 1, type of data, volume, velocity, and variety of data. Everything is changing, batch, in real time. Number 2, democratization of data. Data engineers, data scientists, business, everyone requires access to this data in a much more faster, secure, and consistent way. Number 3, applying more data science and AI, hunger for data to build more accurate models. And number 4, current BI tools are handicapped to manage this structured and unstructured data, which is so voluminous. Let's look at how some of the intelligent enterprises are tackling to solve these problems. This is the conceptual architecture of a lakehouse solution. On your left, you're pumping the data from various sources, RDBMS, NoSQL, it could be logs, events, and other unstructured content. A bespoke data engineering solutions using new technologies can help you handle any form of data volume, velocity, and variety. A change data capture is a software design pattern used to emit the transactions in the form of change logs and feed it to the data platform in a real-time basis. This will reduce the load on your batch data processing as well. And it will give you a data recency or recency to your insights. A data integration toolkit will further connect this data to either a data lake or a data warehousing solution. A modern day data lake solution takes care of providing data in a much more secured, consistent way and having a performant data governance model without technology intricacies. A real-time analytic database is a solution which can further provide strategies to run queries on a large volume set of historical data to facilitate data science hunger, that too with sub-second responses. Real-time analytic database can then feed this data to either a data exploration or a data visualization platform for dashboards and reporting purposes. Even on the visualization side, C-level executives would want to have a slice and dice of data in a much more interactive way without really waiting for their IT teams. The entire solution is going to work like an automotive factory, which means that observability plays an important role for monitoring this entire process as well as intervention. Let's look at how Microsoft Azure can help you implement the Lakehouse solution by using Azure service offerings. Azure Data Factory helps you get the data from various sources to the data lake, which could be HDFS, Amazon S3, or Azure Data Lake solutions. For change data capture and event logs, either you can use Apache Kafka or Azure Event Hub. Azure Databricks is emerging high potential unified data analytics platform. This is built on the pattern of Lakehouse, and it uses Apache Spark libraries and also supports modern programming languages like Python, R, Java, and SQL. Data warehouses are traditionally on-premises solutions for high concurrency, low latency queries and LOB reporting built on SQL Server. But they have a major drawback in being unable to handle unstructured data and machine learning data science workloads. Data lakes such as Hadoop were created to precisely solve this problem, but they had their own drawbacks in performance and reliability. The purpose of this lakehouse is to bridge both worlds, a data lake and SQL data warehouse, into a single centralized asset. The model democratizes the data by keeping data in the cloud object storage of your choice in an open, non-proprietary format that can be read by any downstream technologies. Azure Databricks is optimized to work well with other Azure components, such as it natively works with Azure Data Lakes and Azure Data Factory, Azure Synapse, and Power BI, as well as Azure ML services. Databricks will tackle most of the challenges with respect to volume and variety of data. However, for point performant solutions with data recency, either Azure HD Insights, which is built on top of Apache Druid, a real-time analytical database, or you can use Azure Synapse, which is a new form of data warehousing solutions which uses MPP, a massive parallel processing pattern, for high performance query. This can be either utilized by Power BI for visualization or Azure ML for running data science workloads. Advantage of Azure solutions is all the moving parts are mostly based on open data architecture and integrates natively with other Azure components, utilizing the Azure cloud services in the most efficient manner. The solution can solve the problems of engineering a high volume, high velocity, and highly variant data to fetch real-time insights for decision support.